Let's start with the example 2. Analyze the statically indeterminate frame or a single bay frame as shown in figure using strain energy method. The flexural rigidity is constant throughout the frame. Okay, so this is our given frame or portal frame. Okay, so it's subject to two external loads. One is 20 kN at the middle of the beam, then 10 kN at the top of the column. Okay, then its support conditions are there are two supports. One is fixed support, another one is pivot support. Okay, so I already said it is we would like to solve this problem with the help of energy method. Okay, so energy method is a force method, so that means we have to select the force as a unknown. Okay, so in the force method, forces are treated as unknown. These forces are determined with the help of some compatibility equation. In addition to equilibrium equation, we use some compatibility equation. So with the help of both equilibrium and compatibility equation, we determine the support reaction. Then finally we draw the shear force and bending moment diagram. Okay, so first what to do? So first thing, so we have to determine the degree of indeterminacy. Okay, so the total degree of indeterminacy, it consists of two parts. One is external indeterminacy, another one is internal indeterminacy. External indeterminacy is equal to number of unknown reactions minus number of available equilibrium equations. So in the portal frame, so one end is fixed, another end is pinned, then it's subjected to coplanar. So coplanar is a two-dimensional system, coplanar, non-concurrent, non-parallel system of forces. So therefore the fixer is subjected to three reactions. One is vertical, then horizontal reaction, then moment. Then the pivot support subjected to two reaction. One is vertical reaction, another one is horizontal reaction. So in the fixed support we already know. So it resists both translation and rotation. Therefore it has three reaction. In the pivot support only translation restricted. Okay, so therefore two reaction. So number of unknown reaction will be 3. Then number of available equilibrium number of unknown reaction will be 5. Number of available equilibrium equation is equal to 3. So therefore external indeterminacy is equal to 5 minus 3 equal to 2. Then internal indeterminacy is equal to 3c, 3 times closed cuts, 3 times number of closed cuts. So this is for 2D frames and beams. So in this case there is no closed cut. Okay, so there is no box type of structure. So if you are cut this structure, it is split into two half. Okay, there is no connection between the two portion. So therefore in this case number of closed cuts is equal to 0. So therefore degree of indeterminacy is equal to finally 2. Okay, so the beam is statically indeterminate to the second degree. Okay, so we determine degree of indeterminacy. So the beam is statically indeterminate to the second degree. Then let us choose the redundant. Okay, so in this case I selected VD and HD are the two redundants. So you may select out of these 5 reaction any two has a redundant. Okay, so you may select MA HD has a combination or different combination you may select. So out of 5 you may take 2 has a redundant. Okay, so in this case I selected 2 redundants. Okay, then so since it is a force method, so first we determine degree of indeterminacy, then we selected a redundant. So then we use the compatibility equations to find out the redundants. Okay, so what are the compatibility equations for this case? So we selected one vertical reaction, so another one is one horizontal reaction at D. So therefore compatibility equation will be horizontal deflection at D is equal to 0, then vertical deflection at D is equal to 0. So corresponding to these two redundants. Okay, so our redundants are forces, so therefore our compatibility equation will be in the form of deflection. So therefore delta Vd is equal to 0, delta Hd is equal to 0. Now apply theorem of least work. So we already know what is meant by theorem of least work. For every indeterminate structure which is loaded up to the limit of proportionality, the strain energy is minimum. Okay, so that is partial differentiation of strain energy with respect to any redundant is equal to 0. So our case dou u by dou Vd is equal to 0, dou u by dou Hd is equal to 0. So there are two redundant, so two equations are needed. So the final equation will be, so we already know strain energy U is equal to square root of m square dx divided by 2EA. Okay, so frame is also a flexural member, so moment is the major one, so therefore strain energy is in the form of moment. The final equation will be dou u by dou Vd is equal to integration mx dou mx by dou Vd into dx divided by A equal to 0, first equation. Then dou u by dou Hd is equal to mx integration mx dou mx by dou Hd into dx divided by A equal to 0. So first thing, so before going to determine the moment equation at the every portion of the frame, so first thing we want to determine the support reaction. So for this we apply equilibrium equations. So first apply summation of h equal to 0. So this system is subjected to totally three horizontal forces. So two reactions, one external forces. HA is in HA plus HD is equal to 10. Okay, so we selected HD as a redundant, so therefore HA is equal to 10 minus HD. Then apply second equilibrium equation, summation of V equal to 0. So therefore VA plus VB is equal to VA plus VD is equal to 20. From that VA is equal to 20 minus VD. Then apply third equilibrium equation, summation of moment about A equal to 0. So that is minus MA, then so minus so MA creates anti-clockwise moment, so therefore minus MA. Then 10 kilonewton into 4 meter, it creates clockwise moment. Okay, so 10 into 4 40, then 20 into 3, that one also creates clockwise moment, plus then VD into 6, that creates anti-clockwise moment. Then remaining HD, HA and VA doesn't create any moment because its point of action lies at point A. So final equation MA is equal to 100 minus 6 VD. Okay, our support reactions, we determine the support reactions HA, VA and MA. So it includes both external loads and the redundants. Okay, so it's in the form of both. Now write moment equation at the different segment of the frame. So for this you may make a table like this. Okay, so on a segment, then portion, then limits, then mx moment at the each segment, then dou mx by dou Vd, then dou mx by dou Hd, dou mx by dou Hd. So first consider segment DC. So that is this column, DC column. So our origin is D. Okay, so limits will be, so CD portion will be 0 to 4 meter. So height of the column will be 4 meter. So x is equal to 0 at D, x is equal to 4 at C. Okay, then take section XX at x distance from point D. So what should be the moment? So moment will be minus HD into x. HD, it's create hogging moment, so therefore minus HD into x. Then VD, its line of action is along that point, so therefore it can't produce any moment. Then finally determine dou mx divided by dou Vd. Okay, so there is no term in mx, so there is no Vd term in mx, so therefore it is 0. Then dou mx by dou Hd is equal to minus x. Then consider second portion, CE portion. Okay, so for this, so you may take origin as D or C, whatever it may be. Okay, C or D. So for this limit C portion, so at C x is equal to 0, at E x is equal to 3 meter. So limit will be 0 to 3. Then moment equation. So let us consider a section xx, x distance from C. So moment will be, so Vd, so Vd reaction is creates sagging moment Vd into x. So it is a vertical force, perpendicular distance will be the horizontal distance x. Okay, then hd, hd is also there. Hd creates counterclockwise, hogging moment. So its magnitude, it is horizontal force hd, perpendicular distance will be height of the column, so therefore minus 4 hd. Okay, then dou mx by dou vd is equal to x, dou mx by dou hd is equal to minus 4. Then consider third portion, CEB. Okay, so for this case also I considered origin as D. Okay, so that means we have to consider section xx from x distance from D. Okay, so therefore limit will be 3 to 6. At E x is equal to 3, at B x is equal to 6. Okay, then moment. So I consider right side of the section. So on the right side, so there are 3 forces. So first one is Vd force. So it is a vertical force. Okay, so it creates sagging moment about section xx. Okay, so it is a vertical force, perpendicular distance will be x. So therefore moment is Vd into x. So Vd is the vertical force, perpendicular distance will be the x. So therefore moment about section xx is equal to Vd into x. So this is sagging moment, therefore positive. Then second force will be hd force, that is horizontal force. It creates hogging moment about section xx. Okay, so it is horizontal force. Since it is horizontal force, the perpendicular distance will be the vertical distance. So perpendicular distance is the height of the column, that is 4 meter. So therefore minus 4 into hd, minus 4 into hd. Then third force is 20 kilonewton force. It is a vertical force. It creates hogging moment about section xx. The perpendicular distance is x minus 3, because x is measured from C, so therefore perpendicular distance will be x minus 3.